Analyze the positions of the central atoms on the periodic table. Identify the period of each central atom in the options. Nitrogen, N, is a second period element. Phosphorus, P, is a third period element, and antimony, Sb, is a fifth period element. Apply the octet rule and shell capacity principles. Elements in the second period have valence shells consisting of only 2s and 2p subshells, which can accommodate a maximum of 8 valence electrons for pairs. Because they lack energetically accessible d orbitals, second period elements cannot expand their octet to form more than 4 covalent bonds. Understand expanded octets in heavier elements. Elements in the third period or below possess vacant, low-energy d orbitals in their valence shell, such as 3d for P and 5d for Sb. This allows them to expand their valence shell to accommodate 10 or more electrons, enabling them to form 5 covalent bonds in hypervalent compounds. Evaluate the bonding in Ni5. For Ni5 to exist, the central nitrogen atom must form 5 single covalent bonds with 5 iodine atoms, which would require nitrogen to share 10 valence electrons, an expanded octet. Since nitrogen is in the second period and cannot expand its octet, it cannot form 5 bonds, making Ni5 least likely to exist. Consider steric hindrance as a compounding factor. Nitrogen is a very small atom, whereas iodine is a very large halogen atom. Trying to pack 5 bulky iodine atoms around a single tiny nitrogen atom creates severe steric strain and electron cloud repulsion, further preventing Ni5 from forming. The correct answer is option D, Ni5.